Hello, 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 ladies and gents. This is Ryan once again, coming back with another episode of Small Business Tech. Today, what are we discussing? We're discussing firewalls. Um, I figured that I'm going to try to get to a point where the we're going to try to build a network from scratch, including picking parts and all the things that are necessary for you to build a very capable but still relatively inexpensive um, business network. So, with that said, we're going to start with looking at some basic stuff about firewalls. Firewalls are a great place to start because um, they basically that's kind of where your security begins and more or less ends at the edge of your network, right? So, by the way, let me know how you like this a little bit better. I'm trying a different workflow, and I just want to see how this works out. Anyway, let's try to advance the slide. So, what's a firewall? Essentially, a firewall is the gatekeeper of your network. It can be hardware or software based, or even a bit of a hybrid, thanks to virtualization. So you can run a virtualized firewall, but thanks to some of the features of modern virtualization, you can uh, essentially pass access to hardware, right? So you can do essentially a hardware pass through, to, for example, to a CPU. Now, why would you want to use a real CPU versus a virtualized CPU? Well, that's pretty simple. One, it's faster. There's less latency between the pseudo rendering. I don't know how to what's the correct term to use here, and I try my very best not to mislead uh, by using incorrect terms. So another feature is the fact that modern CPUs have built-in acceleration for things like encoding and decoding and encryption. So, for example, so you have a firewall and you are running a VPN tunnel and you are using AES as your method of encrypting your traffic. Well, most Intel and I'm pretty sure AMD processors at this point support hardware decryption of AES, which means while you can probably do a decent job in software, hardware will always be hundreds, or maybe not hundreds, but definitely. Well, actually, no, I will say hundreds because depending on how much hardware you throw at it, you can scale quite well in how much um, you actually do in terms of performance that you get from hardware versus software. So another thing is, like I said, it controls access to your in and out of your network. You can actually configure your firewall so that no, or either no systems on your network or a certain subset of systems on your network can access the internet, meaning they can't go from your typical 192.168.1.0 network that most of you are used to hit google.com. You can completely stop that traffic. Why would that be useful? In some cases, you just really, for security purposes, don't want your these you don't want these computers to have access to the internet, right? So a good example would be, say, this is not a true air gap because it does have network access, but for example, you may have some sensitive information on one network that you do not want to have internet access to, but you do want your internal users to have access to those systems. And what you would do is you would essentially say any traffic originating from that secured network cannot hit the internet, and only traffic initiated from the unsecured network over a specific port, right? Say a web port like port 80 can pass. Other than that, nothing goes through, nothing goes in and out. It's good use for it. Um, and because of the way firewalls function, especially hardware firewalls, I should be more specific, They are essentially routers also. So lots of times you will hear me or other people referring to a firewall as a router, even though technically it's not really a router. Or I feel like a more common term that people use in the industry is a NAT router, which is probably a more technically accurate term than just simply using the word router. They do network address translation. So what is that? Well, basically, um, without network address translation, you would essentially need a separate internet connection for every computer that you have in your house or in your business, right? Now, think about it. If you have 300 computers in your business, then you would need 300 internet connections. And, while the prices of the internet, price of internet connections have come down dramatically, it's not cheap and certainly not free. So what NAT does is take your one internet connection with your one single IP address, or you can have it with multiple IP addresses. But basically, it does what you call a one-to-many, or a one-to-one in some cases. But typically, what you're going to be doing is a one-to-many, meaning your 64.25.92.36 IP address that's your public-facing IP address that you get from your ISP will look as one device to the internet and the rest of the world, but it will allow the 300 machines behind your network to access the internet through that one network. How that works is it essentially, the firewall creates state tables. Now, I don't want to get too far ahead of myself with that because I do have a bit of an explanation of how that works. Another thing is VPN tunnels. VPN tunnels are a very good way to give your workers or yourself access to resources that are otherwise hidden from the rest of the internet. And the way that works is essentially creates a virtual pipe between your premises, your endpoint, you call it your network, and say an employee, right? And this is especially good if you say run a home business and you have some stuff that you need access to. Lots of people don't trust keeping their documents in the cloud, so they keep it on a file server in their house. But sometimes you're on the road and you need access to that one particular file. So how do you get back into your network? VPN. Now you could do something called port forwarding, which essentially is if you hit your IP address, your public IP address over a very specific interface, then you would essentially be allowed to access that resource. Now that's great, but it is a bit of a security risk. So a better way to do it would be to use VPN. Now, why does that work? Is, well, you have things like encryption in place, but you also have authorization and lots of other security measures that make it not impossible, but very, very difficult for an attacker or just any old intruder to get at your resources. And I already talked about port forwarding. So let's move on. So this essentially is what I was referring to. This is NAT in action, and this is also firewalling in action, right? So in the normal state, the way you and most of the world who are not technical or semi-technical are used to is this scenario where you have a local network, and I don't know if there's a way for me to get my mouse on the screen, but you have a local network, and what happens is you want to Google to Google. So when you type in google.com in your browser, your browser issues a request to the gateway, router, firewall. There's lots of different names interchangeably, but for the sake of this episode, we'll say the firewall. And the firewall will say, okay, and essentially it makes an entry in a state table. And then it forwards that request to Google and basically says, hey, Google, I want to connect to you on port 80, or 443 is more accurate since Google does not accept unencrypted connections anymore. And I'm sourcing my port from 59990. Now this number 59990, it's random essentially, right? So every time you issue a request, uh, your computer, or the client, I should say, will basically issue the request over a random port. So this number will change literally every time, or almost every time. So anyway, moving on, Google sees it, accepts your connection, says, okay, this is your requested payload, being payload, aka website. So it gets back to the edge of your network, which is your firewall. Your firewall looks and says, oh, I have an unexpired state for this traffic, meaning I sent this traffic out to Google on this port, on this source port and this destination port, from my source IP to Google's destination IP. And here I have return traffic from Google's IP and the destination port that I had requested to my IP on the port that I sent the traffic out on. So it lets that traffic through. And that's essentially how it works. So now, the other scenario is this. This is what you want. So this is firewalling in action, just in a very broad sense. So what you have here is Joe's Electronics, and basically Joe's Electronics is just a fictional company that I made up. But Joe's Electronics is going to it has a network, and it wants, Joe would like to basically, well, in this scenario, sorry, I thought I had actually drawn a different one, but in this scenario, Joe is just looking to secure his network. Right. So the way that was working before, someone from the internet, which is what this little blue laptop is, some guy or gal, very equal opportunity attackers around here, are trying to get into Joe's network. So that person hits Joe's IP address, trying to access some application. And in this example, I just used a CRM because it's just this is an example application. So that traffic, on the other side of that person's network, this is what they're doing, right? They're going from their local network to their router. Their router says, sure, I'll establish that connection. It goes up to the internet, and then it hits your router, right? Except in this case, your router gets this traffic saying, I want to connect to joeselectronics.com on port 80 from port 59098, it looks at its state table and says, wait, there's no valid outgoing session. Remember, the traffic originated from the outside of the network, not inside, so there's no state table. And there are no rules that said this traffic is allowed to pass. Therefore, the response is either silent, it silently drops it, in which case the connection times out and you get no response, or it just sends back an ICMP response, what we call an ICMP response, basically saying connection refused. And that's essentially how we want things to be. So, with that said, I am going to try to do something I haven't done before. I don't know if this will work, but it's always worth a shot. We know how well live demos works for professional guys. So let's see if we can get a live demo working here. So this is just a shot off of my Mac Mini that I have running next to me here. And essentially, this is just showing VMware. As you can see, I have a little virtual machine running here. And it's running essentially a web server. I'm not going to get into what the operating system is because for our purposes, it doesn't really make a difference, right? So we won't get into that. But I just wanted to show you that it was there. If I if I ping it the way you would ping a website on the internet, I would get a response. So let me bear with me here, guys. Like I said, trying a new process. But let me bring up different. So we bring up a terminal here. So this is just a regular terminal. It's live. See, you can see. So it's basically just a it's a server. It's called web demo, and all it is a web server. For those of you, well, I'm not even, like I said, I'm not going to go into that. I'm going to try to keep this as simple and high level as possible. So that is just a web server. And essentially what I'm going to do here is, just again, just to prove a point, I am going to try to pull up. There we go. Okay. So I'm going to pull up a web browser. Now, I was lazy and I did not include anything particular with this website. It's just the basic default website that you would see if you loaded this, if you installed a web server software, right? So let's see here. Let's go back to the terminal, and if I ping 172.126.128, we have to type the IP address correctly, we get a response. And if you look in my web browser, right here, that's the IP address that I have entered in here. Now I hope, nope, that didn't, that just made it worse. Let me scale that back down. Hopefully that recovers. Okay. Let's see. So it looks like I screwed up my display a little bit, but hopefully I can. Anyway. So going back to web browser, this is just default. Right? I can load it, refresh the page all day. That's not going to do anything. Now, the reason that works is because, going back to my web server here, this server has a software firewall. And in this case, it's called Uncomplicated Firewall, or UFW. So the commands I'm typing don't matter. Again, this is just a very, very high level. I can't spell. It's a very high level overview. So you can see the firewall is loaded, but it's not running. So let's start it up. And we want to see if I can remember the commands correctly. UFW add TCP/22. Nope, that's not it. It is add port. Like I said, live demos are awesome. Okay, so it's CC, so it's allow, and I did firewall properly anyway. This is 22/TCP. There we go. And I'm going to do UFW enable. So the reason why I did that was because I when I turn the firewall on, by default, it's not really it's set to not allow any traffic in. And since I want to maintain my SSH session, which is or my terminal session, I needed to tell UFW to allow SSH traffic through. Now, if I switch back to my web browser, remember how easily it was for us to reload this page? Now notice it's just spinning and spinning, and eventually it's going to time out. And the reason for that is because we're now around port 80 through. So, if I were to enable port 80 and issue a UFW reload, which basically tells the firewall to reload its rules, it should have new rules in effect. And now, I thought I was going to say demo fail. But there we go. It's loading the page just as it was before. And that really is the power of firewalls and why they're important. Now keep in mind, that was also just a software-based firewall. And because it was software-based, it doesn't quite work exactly the way you well, I guess it works exactly the same. I'm sorry, it's late. But it's a software firewall, so like I said, the performance is very good, especially on modern silicon. However, a hardware firewall is definitely going to be a lot faster, and which is why typically any firewalls that you would buy from the store or from a vendor would do most of its work inside of the hardware. Now, because I was, well, I don't want to say I was lazy, because I need to edit this. Okay, so I pre-recorded some stuff for you regarding firewalls. Just want to make it easier to show you. And also, I'm trying to get a little bit better at this content thing and preparing. So let us get going with the first one. So this is a typical NAT router that you buy from like your Best Buy or any electronics store. Yes, this is a firewall. It will perform most of the functions of any firewall, including NAT routing, stateful packet inspection, and also you can do things like port forwarding. And this one actually supports a little bit of dynamic routing, which is a topic that we haven't gotten into, and I'm actually not sure if I will get into for the purposes of the audience I'm targeting. But yes, you can start with this. It's I believe I paid like $100 for this. By comparison to some of the more advanced routers I'm going to show you, it's relatively slow in terms of how many packets it can forward and how much state it can handle, and also it doesn't do VPN or any sort of VPN tunneling. And that was sorry, I forgot I had myself muted there. And that was the first one. I believe I have 3 of these. But that is, I just wanted to show you that yes, the NAT router that you buy from your electronics store for Amazon is not necessarily a bad choice. It is just lacking in terms of features and of advanced features, things like hardware acceleration, VPNs, dynamic routing for if and when you need it, things like that. Also, the way these things are built essentially is the vendor tries to put in the cheapest parts they can put in to allow them to sell it for the price point that they want and still make a profit. So in other words, you're probably looking at a CPU and memory in there from a computer that was probably in the mid to early 90s, maybe a little later, closer to 2000s, but it's not really that powerful. It can't handle a lot of traffic by comparison. It cannot do it cannot do encryption or decryption, hardware, especially in hardware or software. Now, I shouldn't say I don't want now. This isn't a blanket statement because there are ways for you to modify some of these to put more advanced software on them, and in some cases, you may even get lucky and the underlying processor may be capable of doing hardware accelerated functions, but they may not be enabled in the default software. Anyway, so our next one is going to be a Cisco ASA. And continuing our theme of demonstrating some devices for you, this here is another firewall. It is the Cisco ASA 5505 series. Let me try to zoom in on there. And ASA stands for Adaptive Security Appliance. This particular model has been end of life and it's no longer being manufactured or probably even supported. And I believe, in fact, that Cisco is either discontinued or deprecating the entire ASA line in favor of their Firepower line. But this is kind of looks like a green cable box. Turn it around. There's a lot of ports on here. The difference being that this looks a lot like a typical home router without the wireless. As you can see, there's no wireless antennas, but there's a lot of ports. The difference being between this and typical wireless router, as far as the ports, is usually in the consumer router, one port is usually where your internet comes in, and the rest of them are usually bridged together. Essentially, they're switched. Now, these ports can be made to run in switch mode, just like a home router, but by default, they are actually isolated. So, in theory, there are 8 ports. You can run 8 individual networks on here. Another thing about this is you can install some optional modules to give you some more features. Even though this has been discontinued on eBay, and this has been discontinued from sale, you can buy these on eBay for usually about $150. So what are the quick features of this versus a typical home or prosumer router? This firewall / router, and sorry I keep using the word interchangeably because, as I said, firewalls tend to be routers also. Let's see, this supports VPN. Both SSL and IPsec VPN, both site-to-site, meaning you have a virtual tunnel over the internet from your office to, say, your home, or your office to your other branch office. And in the typical, what we call a road warrior mode, where you have a laptop and you're in a Starbucks and you want to do some work, you connect back. You can do that with this. It supports a lot of the typical NAT routing and port forwarding. It supports one-to-one NAT, one-to-many NAT, which is what people are more familiar with, and a bunch of other stuff. Finally, as far as my video demonstrations here, this is a 40net, 40 Wi-Fi 60C. It's another old device that's been discontinued. I believe they discontinued this after they bought, Maru. But this looks very typical, like your regular consumer Wi-Fi, NAT router that you buy. Same as before. You can see a lot of ports. In this case, these ports 1 through 5 are bridged, just like a consumer router, and these ports 1 and WAN 2 are not bridged, and that's your DMZ port. This also does wireless, whereas the ASA does not do wireless. Not only does this put out wireless, both 2 gigahertz and 5 gigahertz wireless, but this also has a built-in wireless controller. So if you have other Fortinet access points, you can actually control them from this, as in give them SSIDs, passwords, things of that sort. And all right, guys, that'll do it for today's show. Let me know how this went. I know it's a little rough. And I need to do a little bit more preparation. I need to streamline my workflow a little bit better. And I need to stop doing that. Anyway, this is Ryan. Hope you guys enjoy, and thanks a lot.